Alright. Right now our house is being remodeled, so my room is being used as a storage room right now. Right now I have this fan blade. The same fan blade as earlier, but I'm using 380 volts approximately, and the amps are going from 0.01 to 0.04, sometimes at 0.05. So let's say the average amps we're using is 0.03. Now I've straightened this coil and made some adjustments to it so that it's tighter. The result, it's slower, but the force is greater. As a result of this better alignment I've used protractors and other things. Now the problem is the air is not moving as fast, so most of the pressure generated by the device is static pressure and not velocity pressure. So as you can see, the velocity of this blade is not as fast as in other videos. It's about the same as in my previous video, which is 210 RPM. Actually, I can get this thing up to, say, 340 RPM. But to do that, I'll have to adjust this commutator. Before that, though, we're going to notice that we can see movement in the plants, and you can also see it through that video over there in sharper detail. But now let's check the current again. 0.01 to 0.04 amps, but like I said, sometimes it goes to 0.05. So the average being, let's say, 0.03 amps. Now, before we measure the voltage, I'm going to go ahead and adjust the commutator. Now I'm going to position this so that perhaps you could see better how I adjust the commutator. Now, might as well pull this out first. Okay. Let's pull this a bit forward. Hopefully I do this right the first time. Let's see. I'm pulling this thing forward so that it will be contacted to it longer. So we're going to go ahead and see if there's any change. Okay, it's a little bit faster. Fine enough. Now the current is still being drawn from... Actually, you know what? I never seen this before at all. After all of these times, I haven't seen this, and I'm just recording this right now. Now, we don't have the battery indicator here, which gives me a little bit more confidence that this is actually measuring it accurately. But seems that we're having significant back spikes right now. Now this is the decimal point. There's a decimal point. 0.03. Okay, I just did this. I just made this happen, and I didn't even try. Well, apparently, if I bring it to the 20. Oh, okay, crap. You see this camera? Again, I put the camera too close to the thing. I'll have to reset it. Now, off, back on. Now, I'll have to turn the camera entirely off. Now, it will have the other file saved. Now, turning this back on. Alright. Now, let's go back. We still have but anyway, that just shows that there's big back spikes. I'm not sure how long this will really last, because even with these, we're not sure. Now, if we go to the 20 amp setting, and at AC power, it will give us attempt to give us the root mean square current. But if the back spikes are too large, then we won't get that. Those values. Let's see. Now, it's going off the scale, going from 3 amps to 12 or whatever, but that's not accounting for the low power factor of the circuit. Okay, now I just made this happen. I didn't even try to do this, but normally it's down to 2 or 3 amps of AC. Now, this is just recent. I just made this happen. Okay, that's the last time I'm gonna say it. Now I'm gonna measure the voltage. Okay. Now the voltage. Okay. Better way to measure it is directly to this. I'm gonna insert this over here. All right. We measure 286 or 287 volts or 288. The straight charge is developing back. But the strangest thing is I didn't have it at this higher voltage earlier. Or, no wait, that's it off by 100. Earlier it was 380 volts. Now it's taking a long time to rebound to that old voltage. So we see by how we were running it, the voltage went down big time. Yeah, that's the nature of the batteries, okay? Because the way it was drawn, or whether it's forwards or backwards, that's what happens to the voltage, okay? Now I can go ahead and remove this thing again and reconnect it. Okay. Make sure I do this right. See how we can get this time. See if we can replicate it or whatever. Let's see. Okay, again. We still have the back spikes. Now, their back spikes are represented by spikes in current. When measuring on the meter, where this will show the RMS. So the RMS is always higher than the average, because RMS means root means square, and mathematically, if the current changes, the RMS must be greater than the average, and so it is. Now, bringing it back down to the DC current, we get the same thing that I got with my older, smaller motors. But now, unlike previous videos, I finally got this big one to do the same thing. When it's doing things like this, normally this machine will run for 2 hours, no, 2 days straight, as long as everything remains intact, which I have done several times with different motors. So this will be it for now, alright?